All right. Hello and welcome to your last lab, Lab 6. You made it. This one's going to be about permutations and combinations. We're going to generate them, which means essentially we're just going to copy the code from our book and call it a class. Okay? So I really don't have a lot to talk about in these slides, but for your convenience, I have pasted the 4 functions that you will be implementing. Okay? Generate lex permutations and then next perm, and generate lex subsets and next subset. Okay, so as long as you understand these functions, you are good to go. Just get them implemented. Okay, so let me go over the write-up with you, and we'll talk about how it's slightly different what we're doing is, because those functions, they're not as general as they could be. Okay, so especially the permutations ones. I kind of did the combinations for you. So yeah, get the code. It is all these files. You're going to be working in generation.h, which might be surprising because usually we don't work in header files. So the point of it all is we're going to use templates. Okay, we're going to be permuting and combining any type that can be compared. Okay, that's the beauty of it. So yeah, let's go to, I guess, generation.h, and then we'll talk about it. So here's generation.h. You will be implementing all of these functions. So the first one is next perm, and different to the book where you're given like a sequence of things as a bunch of parameters, we're just going to get one big vector. Okay, that's what we're going to be doing. That's the first main difference. And so then you're just going to output another vector, which is the next permutation of that first one. Okay, that's all. So next perm of that should return that. That's the idea. Yeah, that is what's going on there. That's how next perm should be implemented, and it's going to be templated because we can have a vector of anything. It doesn't have to be numbers. It could just be strings if we wanted it to. We can just as easily use the book's code to like implement it to compute the permutations of like a vector of strings. It's not a big deal because we can order these things. Like blah comes first, then hello comes second, and then world comes third. Actually, don't quote me on that because the capitals might throw everything off, but I think you understand what I mean. All right, so yeah, we're going to use templates for everything. Anytime we see a sequence of things, we're always going to use a vector to represent that sequence, even if it's like supposed to be a set. Okay, like next subset. We want all this stuff to be in order, and so we can't just use sets. We have to use vectors. Okay, so same for gen lex subsets and next subset. So next perm looks like that, and then we have generate permutations. I guess I should talk about this before we get on to the subsets. Again, we're going to take a bunch of items that we want to permute, and yeah, it's just going to be of type t instead of int. That's all. And instead of outputting those permutations, that's the other key difference for this one. Instead of outputting the permutations, we're going to be building up a vector of permutations. So a vector of vectors, because each permutation is its own little vector in here. Okay, so you're going to be giving back a vector of all the permutations that you compute in that order. So just every time you see a new one, it's more like push back. Like all the permutations push back the next one. Okay. So instead of this line, you'll just be changing this to like some kind of like perms dot pushback next perm dot dot dot, and you'll be at the very end, instead of like outputting things, you'll be after the loop is done, you'll say return perms or something. That's the idea. Okay, so that just makes it easier to test. If you don't output and I check that the vector of all the permutations is in the right order. Okay, so let's generate permutations. Please yell at me if you have any questions. You can assume that there's no duplicates in items because things get weird in that case. Yeah, the first permutation, because it's not numbers anymore, it's just the sorted version of this, and then the last permutation of the items is the reverse version of the sorted vector. Okay, that's all for permutations, and now for subsets. Okay, these are exactly the same. So you are going to be given for next subset a number n, and then your current subset that you're working on, the one that you want to find the next one for, and that is actually the same. Okay, so that's all matching. That's nice. And so you'll use the same thing. You'll return back a new vector that is the next subset, okay, in the proper order and everything. And then you'll use it all here to make the first one, make sure it's not the last one, and keep calling next subset. And again, you're going to be pushing back instead, okay? Dot, 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 push back. Because you're going to build up a vector of vectors of all the different combinations, okay? Vector of vectors, so each subset is an element of this outer vector. Gotcha? So, yeah, again, you, oh, oops, I'm sorry. It is this one right here. So again, you're building up a vector of vectors. That one below I've already implemented for you. And so yeah, it takes the R and the N, so you're going to make a bunch of R subsets of all the numbers from 1 to N. Yeah, that's the idea there. And yeah, this one isn't doing normal item permutations. I've implemented that for you down here. So I made a generate combinations function that just works. It's going to use your genlex subsets to generate the indices of a generic vector of anything. Isn't that cool? So yeah, that is the idea there, and that is what you will be implementing. So these 4 functions, they're almost exactly the same as what you have in the book, just slight differences, like you're not outputting things, you're adding to a vector, and for the case of permutations, we are dealing with any type. It doesn't really matter. Okay? That is the idea there. And I do encourage you to look at all the tests because they tell you exactly what needs to be given back. Okay? Like if I give you the numbers 1, 2, 3, 4, 5, this is exactly the permutations that you need to generate in this order. Okay? I have numbers, and then I have more of strings, permuting strings, and then I'll check your generate all the subsets of size 3 from all the numbers from 1 to 5. This is what you should give back. And then finally, I'm going to test your genlex subsets with my implementation of generate combinations as well. Okay, so that'll make it work for any vector of anything. So it makes little subsets of a certain size. Okay, so those are all my tests. Got 4 of them, and you will also be implementing 4 functions. So please let me know if you have any questions at all. It'll mostly just be copying and pasting from the book, but there is a little bit more than meets the eye. Like how do we find these K's and all this fancy stuff? That is something you have to think a while about. So I think that's all I have for you. Do reach out if you have any questions at all. Yell at me. And yeah, good luck. This is your last lab, so let's finish strong. And yeah, let me know if you have any questions. I will see you later.